Okay, so this lesson is about working at the midpoint of a line segment and finding the equation of the perpendicular bisector of a line. Please pause this video throughout to take notes and to work out the questions. So the first thing we're going to talk about is the midpoint of a line. And the midpoint of a line is pretty much what the word actually means itself. It's the middle point of a line segment. So we've got a line segment here that joins 2 points P and Q, negative 2, 1, and 2, 5. And what we want to do is just find the middle point of that line. Okay, so you might be able to work that out in your head, or you might prefer to have a look at a diagram of P and Q and think about it that way. Now, when we're thinking about the midpoint of PQ, the diagram really emphasizes it's really easy to see where the middle point is. But the other way that we can think about it is thinking about, well, we want the halfway point between the two x coordinates and the halfway point between the two y coordinates. So we can see there between negative 2 and 2, the halfway point would be 0, and between 1 and 5, the halfway point would be 3. So therefore, a midpoint is 0, 3, and we can express it like that. Okay? So what we're going to do now is I want you guys to work out some midpoints between each of these line segments. So if you pause the video now and work these out, I'll reveal the answers next. So hopefully we've worked them out and we've gotten 5, 7, negative 4, negative 10, and 1, 5. What we're going to do now is we're going to talk about how to express the midpoint mathematically, because we like to express things using a nice mathematical formula. So if we think about our midpoints being x1 and y1 and x2 and y2, or 2 points I should say, then we can think about our midpoint and how to express that. So what we're doing really is we're adding our x1 and our x2 coordinates together and dividing by 2. And we're adding our y1 and our y2 coordinates and dividing by 2 to get the middle point. So we can express it like this. So the reason why we can express it this way and what makes this quite useful is that when we've got 2 points where they're not so easy or they're not so straightforward to get the midpoint, let's say you're going to end up with a fraction, then you can do it this way and it works out quite nice. So I want you to try this one now and see if you can do it. So pause to work it out. Right, so we should have got an answer of 1.5. Okay, so that's our midpoint there. Hopefully that's figured up everything with the midpoint for you. Now we need this midpoint because we're going to go on to our next topic, or next part of the topic, which is perpendicular bisectors. And perpendicular bisectors, like midpoint, kind of the word itself explains what it is. So thinking of the word perpendicular, that's meaning at right angles to, you should hopefully already know that. And bisector meaning to split something into, cut it in half. Okay, so a perpendicular bisector is a line that bisects another line at right angles. If you have a look at our diagram, just going to explain it here. We've got our line segment AB, and our perpendicular bisector is CD, and that splits this line in two. So CD is the perpendicular bisector of AB. Now what we want to do is we want to find the equation of this perpendicular bisector. So what we're going to do is we are going to have a look at an example. So this is our example here. We want to find the equation of the perpendicular bisector joining these 2 points. So if you want to try and figure this out yourself, what I suggest you do is pause it and have a think about what you could do, and then I'll tell you at different points where you can pause and work it out step by step. Okay, so I'm just going to first start off with drawing a diagram of our C and D, and we're looking for the equation of this line here, the one that splits C and D, the line segment going from CD in 2. So if we think about it, that point there, splitting it in 2, so that point must be the midpoint. And for an equation of a line, you're thinking, well, what do I need? I need a gradient and I need a point. So this midpoint would be our point on our line. So that's what we're going to first work out. So you can pause it for a moment to work out your midpoint. I'm going to show it here. So our midpoint is really 1. So the next thing we need for our equation of a line, hopefully you're thinking about it, you're thinking, well, I need a gradient. And if you think, well, I need the gradient of this line here that's perpendicular, we can mark in our right angles here, perpendicular to the line CD. So we already know how to get the gradient of CD by the 2 coordinates, so that's fine. So then all we have to do is state our perpendicular gradient. So I want you to work that out, and I'll give you, well, just pause it for a moment. Okay, so we should get our original gradient of CD as being negative 4 over 5. So therefore our perpendicular gradient will be 5 over 4. So our last step in this is to state the equation. So that's what we're going to do just now. We've got our point and we've got our gradient. So if you want to pause it, if you haven't already written your equation, do that now, and I'm going to reveal the equation. We should have 5x minus 4y minus 11 is equal to 0. Okay, so a little summary of what we do to get our perpendicular bisector. We get our midpoint, we then get our perpendicular gradient, and then we state our equation. So I'm going to write that in a nice little summary. So 1, find the midpoint of the line. 2, find the perpendicular gradient. And 3, state the equation using the midpoint and the perpendicular gradient. So what I'm going to do now is give you some questions to try. So these ones here, give them a go, and I'll reveal answers on the next page. So pause just now to do the questions. Okay, so here are your solutions to the questions. They can be in any form. I've written them in the general form of the equation of a line, but you can write them as y equals x plus 4 if you want as well. That's perfectly fine. As long as you've simplified the whole numbers, that's fine. So check your answers and see how you did. Right, we're not yet finished just yet, so we've just got a couple of other things I want to talk about. Is that when you're thinking about these exam style questions, they don't often always come up in triangles with perpendicular bisector. We sometimes talk about other shapes as well, and that's what we're going to look at just now, is some of the shapes that you can find perpendicular bisectors in. So if you have a look here, the first one, you can remember this one from back when you were in 3rd or 4th year. We talked about a line drawn from the center of a circle down to a chord bisects the chord. Okay, where it also appears as in a rhombus. A rhombus, 4 equal sides here. We've got the diagonals of the rhombus cutting at right angles as well, or bisecting at right angles. And the same with our kite. Okay? So quite important to be aware of the shapes that come up and where the right angles appear. So you need to kind of think about and remember even where the right angles are appearing. The last little bit of perpendicular bisectors is when you get something called the circumcenter. So it sounds fancy, it's pretty straightforward. So if you have a triangle and you get the perpendicular bisector of each of the sides of a triangle, like so, they meet at a center point, and when 3 of these bisectors meet at a certain point, then it's called concurrent, and they meet at the same point. So they meet at a center point here, and this is what's called the circumcenter of the triangle. Okay, now what else can happen here is that if you draw a circle around the outside of this triangle, where each of the vertices touch the circle, this circle is called the circumcircle of the triangle, and its center is actually this circumcenter here. So this kind of question might not necessarily come up in a straight line, but it could come up in circle, and it's more just to be aware of the vocabulary circumcenter and circumcircle. Okay. I hope that this has helped your understanding of perpendicular bisector, and we'll work on some exam style questions tomorrow. Thank you for listening.